Hello everyone, welcome back to Unshackling Sudokus and Puzzles. Today I've got a classic Sudoku with a really unique name. It is called the sofa problem and it's created by Aron. We have covered a classic Sudoku by this author in the past as well. A really nice classic Sudoku. Many of you viewers enjoyed the video. So this is another classic Sudoku by the same author. And like I said, it has a really unique name. It's called the sofa problem. The link to solve the Sudoku is in the description of the video. Please do give it a try. Come back and watch the video. And if you are enjoying our videos, please do support us by subscribing to the channel. And if you're really loving the work we do, you can consider supporting us on Patreon. The link is in the description of the video. So let us start the Sudoku by Aron. Classic rules apply. Each row, each column, and 3x3 box in the grid has digits 1 to 9 without any repetitions. So let us start the Sudoku now. Right, 4, 4. 4 can go in all these cells. 4, 4. So 4 is in these 3 cells. It has a really unique solve path. As I've solved this classic already, I know it has a really interesting solve path. Okay. Nothing much with the 4s. There are lots of options. So let us do something with 7. 7 goes here. Again, 7 has lots of possibilities in other boxes. So it is better to start with center candidate marking because you can see that the givens are really uniquely placed. So let us start with center candidates. These two cells can't take 1, 2, 4, 8, 7 and 9. So 3, 5, 6. And I can't have a 3 here. This is 5, 6. This is also very restricted. Let us mark these digits in. 2, 3, 5, 4, 6, 7, 1, 8, 9. 1, 2 and 9. 1, 2 and 8 and 1, 2 and 9. Right? So as I was solving this Sudoku and I was kind of looking for things in the middle of the solve, what caught my eye was this area really. Right? I was thinking there must be something because this really looks too suspicious to be kind of coincidental. There must be something that the author has tried to hide in here. So I was looking in that angle. So in fact, I had pencil marked all these cells, right? Regardless of the number of candidates, I straight away went for pencil marking these cells. And I was not surprised when I found that there is something hidden in those cells. So let's continue now. 2, 4, 5, 3 and 8. So 1, 6, 7 and 9 in row 3. 1, 7 and 9. 1, 6 and 7 and 1 and 9. Right? Let us finish this box. 1, 2, 5 and 9. This is 1, 2, 5. This is 1, 2, 5. And this is 1, 2, 5 and 9. Right? 9 cannot go in these cells. Now coming back here. 4, 5, 6, 8 are already givens. So 1, 2, 3, 7 and 9. This is 1, 7 and 9. This can take everything. 7 and 9 are ruled out. And this is also 1, 2, 3, 7 and 9. Excellent. So there is just one more area left for us to, aggressively pencil mark. And then we can set sail along the path to the solution. So let us go to that area right away. 3, 4, 7 and 5, 8 and 9. So the remaining digits are 1, 2 and 6. Let us place that in. And these two cells cannot take 1, 2. 3, 5, 8, 9 and 1 and 2. So 4, 6 and 7. 6 doesn't go here and 7 doesn't go here. That's excellent. Is there any area which I can, maybe this column? This would help us in the solve later as well. 1, 7, 8, 9. This is 1, 8, 9 and this is 1, 7 and 8. Right. So I have reached the point where I would like to, and I'm going to show you the trick to solve this interesting classic Sudoku. So at this point, there is a really beautiful logic. Let us see what that logic is. You can see that 1 and 2 are spread all across these boxes. So I was thinking, what happens if both of these cells are a 1 and 2? That is, they don't take a 6 in them. There is no 6 in them. So if I have a 1 and 2 here, the 1 and 2 goes in this capsule in box 7. The 1 and 2 goes in this capsule in box 1. The 1 and 2 goes in this capsule in box 3. And lo and behold, there is no space left for 1 and 2 in box 6, because the moment these become, right, let us go back in order. Where do you place 1 and 2 in box 6? Right? 6 cells are already eliminated and you have eliminated these additional 2 cells. That leaves just 1 cell to place 1 and 2. Not possible. This proves that there must be a 6 in one of these cells. I wonder how a solver will try to solve the Sudoku, whether it will try to brute force the candidates and make eliminations, or it will find this elegant path as well. So 6 has to be in one of these 2 cells. If not, then we are hitting with a contradiction in box 6. So which means the moment I get a 6 here, this is a 4, this is a 7, and this will be a 1 and 2. And now in column 4, 5, 6 and 8, the remaining digits, this is not 6, so 6 goes in here. Do stay tuned. The Sudoku doesn't, end here. There is some really good logic that you can use at this point. So let us use that. 1 of 1 and 2 is going in here, right? Because this is a 1 and 2, so 1 of 1 and 2 is going in here. Let's color this pink maybe. So if this is yellow, this would be pink, because 1 and 2 are opposite. So this yellow cell here, regardless of whether it goes in here or here, it must be in one of these 2 cells. So I'm going to mark them both as pink. Both as yellow, right? Now the yellow cell in box 1 must be in one of these 2 cells. It cannot be anywhere here, so it must be in one of these 2 cells. And I'm using the same logic in box 3, so yellow goes here. And now in box 6, this is beautiful. The yellow cell has only 1 cell left, cannot be in any of these cells. It has to be here. And we do know that it has to be a 1 or a 2, because that's what we started the chain with. We assumed this as pink cell, so the other 1, 2 must be in one of these 2 cells, and we call that as yellow. So that yellow we propagated all across the grid and ultimately ended up having that yellow cell here. Excellent, right? Now let's try to propagate, if possible, this pink cell. So pink has to be in one of these 2 cells, right? Obviously you cannot have a pink again here because of the reason I showed you. If both yellow and pink are here, so that means this will be 1, 2. So this becomes 1, 2, this becomes 1, 2, and box 6 is broken. So pink has to be in one of these 2 cells. That is nice. And now I have an invisible pair, right? We do not know which cells exactly take 1 and 2, but we do know that there are 2 cells out of these 2 capsules which take 1 and 2 among them, which means these cells cannot take 1 and 2, 5, 6, 8 and 9. There is no 9 here and there is no 8 here. Interesting. Now let's use some reverse logic here. I do know that the pink cell cannot go here because, again, the same problem. So the pink goes here. Now I'm coming in the reverse direction. Now the pink cell in box 1 cannot be in these cells, so it has to be here, right? So we have kind of reached the same point. Now I have a 1 and 2, again an invisible pair in box 1 in these 4 cells. So this cannot be 1 and 2. This is 3, 7 and 9. Excellent. Really beautiful logic. So let's continue. This is actually not a 7. And there is no 2 in here, so 1, 3 and 9. There is no 9 here, so 1 and 3. Very nice. So let's try to continue from here. Okay, so the 1 and 2 in box 6 obviously has to be in one of these 2 cells. We do not know which one yet. And propagating the logic, 1 and 2 must be in one of these 3 cells, but because one of these cells is 1, 2, so one of these 2 cells is 1 and 2. But we do not know which one yet. But we would dearly love to know, because if we could find a pair here, then we can eliminate some more digits from here. But for now, 1 and 2 is in one of these two cells. Excellent. Okay, let's continue now. These two cells cannot take 1, 2, 4, 6 and 8. So 3, 5, 7 and 9. And 5 and 9 don't go here. So 3 and 7. Okay, in row 9, 1 and 2 is in these three cells. So this is not a 1 and 2. In fact, because of the 4, 4 is eliminated here. And this has to be a 6 or a 9. Excellent. 1 and 2 will be in here in these three cells. Oops, sorry guys, sorry. That was not a good logic. Actually, we do not know if 1, 2 is here, right? Because it is in these two cells. So I cannot, use this way. But I do know that 4 is in these two cells, so that Snyder notation of 4 goes here because of this 4. Now 6, so 6 is in here. And the pink has to be 1 and 2, so it is 1, 2 and 6. Okay, 6 is eliminated here. Yeah, both the cells. 1, 2 is in these 4 cells, so this one right here cannot be 4, 6, 7, 8, 1 and 2. So it is 3, 5 and 9. So it is actually a 9. Beautiful, a hidden single. Because of this 1, 2 invisible pair, we get a hidden single here. It has to be a 9. And that gives 5 in here, 8 in here. 9 doesn't go here, so 1 and 2. Excellent. Now I know that 1 and 2 is here, so this cannot be yellow anymore. This is the 1 and 2. Whichever goes in here, it has to be here. Okay, the 3 in box 9 has to be here, so this is a 1 and 2, right? This yellow here cannot be here, so it goes here. Excellent. So I have a pair now, 1, 2 pair. This is 8. This is lovely logic, really. Don't have 8 here. This is not 8. 1 and 9. Okay, 4, 4. So 4 goes here. That is nice. 5 is not here. So 1, 2, 9. And 3 and 5. So this is a 6. Beautiful. So that is a 5. This is not a 5 anymore. 1 and 2. Again, a 1, 2 pair in column 9. So this is a 6. The moment this becomes 6, it loses its, color. So 1 and 2 is here. And this is the pink 1 and 2. So I have a pair now. 1, 2, 1, 2. So this is 9 and loses its color. All right. So 9 here removes the 9 from these three cells. And now that gives me a 9 here. Which means that cell loses its color. And this has to be 1 and 2, right? The pink 1 and 2. So I have a pair now, 1, 2. Beautiful. So 4, 8, 9 and 1 and 2. So these cells are 3, 5, 6 and 7. 5, 6. So this is not 5, 6. It's not a 7. 3, 7, 3, 7. So this is not 3, 7. And 5 is already here. So that is a 9. Look how the solve progresses brick by brick, guys. Beautiful creation. Not too hard and not too easy as well. I'm saying not too easy because you need to find that logic with the 1 and 2s, and if not, you're stuck. And I'm saying not hard because it is clearly telegraphed, I would say. Right, continuing on, the 1, 2s have not been resolved here. Okay, anyway, 5, 8, 5, 6, 8. Okay, 9 is in here, so this is a 1. This is 2, 5. Okay, I've got yellow as 1. So this is not a yellow anymore, right? Yellow is 1 or a 2. And the moment one of 1 and 2 comes in here, the other cell cannot be yellow. So now I know all the yellows are 1. Let's put them in. So all the pinks must be 2. The sure pinks. These are all pinks for sure. Beautiful. So this is 1, 6. What am I doing? Yeah. So that's a 9. This is 2. Very nice. That's not 2. 1, 3. So 1, 3, 7. 2, 6, 9. So these would be 4, 5, and 8. Really beautifully building, guys. The Sudoku, I'm really fascinated by Sudoku. This is 5. This is 2, 3. This one gives a 3 here, which instantly resolves this 2, 3 pair. 3 gives 7. Gives 3. 7 gives 3, 1, 7. And wrappers are being thrown all over the place in utter joy. Right. So this is not a 1. This would be a 1, 8 pair. This is 8. This is 1. Oops. 1, 3 gives me a 9. These two cells can be resolved. 5 and 6, right? Not it. 5, 6. So I do have a 6 here, which means I cannot have a 5 here because that gives rise to a deadly pattern, or in other words, the unique rectangle. So which means I can put the 5 here, because if not, this becomes 5, 6 and this becomes 5, 6, and the Sudoku will have at least 2 solutions, but we do know this has a unique solution. But anyway, can be done without the uniqueness technique. 6, 7, 1, 3. All right. 4 is in these cells. 3, 4, 7, 1 and 9. 2, 5, 6, 8. 2 doesn't go here. That leaves only one cell in row 6 for the 2. This is 5 and 8. So 5, 6, 8 triplet. This is 4, 7. Excellent. 8 is in here, so that's a 5. Which means this is 6, 8. That gives a 5. This is a 4, 8. Beautiful, guys. Absolutely beautiful. So 5, 6, 6, 8. And we can finish off the end of the Sudoku with a flourish. 4, 8. 4, 7, 7, 6, 6, 1 and 1, 3. I would really rate this Sudoku very, very highly. Let me remove this yellow, right? And this thing. So a beautiful Sudoku, which started off by identifying that one of row 7 column 5, 6 has to have a 6, because if not, then box 6 is breaking. So do share your thoughts in the comments. Did you solve the exact same way, or did you find something else? We would really enjoy reading your comments. Hope to see you soon. Bye bye.